That hurt me. Notice here, I just punched the wall. A punch is a push, which means it's an example of a force. But my force was applied to the wall. Why does my hand hurt then? The force was applied to the wall and not to me. Hello, everyone. I'm Mr. Pinola, and today we're going to take a look at why my hand hurts when I punch a wall and other similar examples that clearly show Newton's third law of motion. Newton's third law of motion. We learned that Sir Isaac Newton introduced 3 famous laws of motion in his book Principia. We already learned about 2 of them, but here is the third of Newton's laws. It states that for every action force, there is an equal in magnitude and opposite in direction reaction force. Maybe you've heard this law simply stated as for every action, there is an equal and opposite reaction. I like to be a little bit more specific than that. And I like to specifically say that it is an action force that we're referring to and a reaction force that occurs as a result. I also like to be a little bit more specific about the words equal and opposite in our definition. When we say equal, we are referring to equal in magnitude or size. And when we say opposite, we mean opposite in direction, meaning going the other way. So let's read this law one more time, and then we'll take a look at some examples of how it works. Newton's third law of motion says that for every action force, there is an equal in magnitude and opposite in direction reaction force. So let's go back to our example of me punching the wall before, something that you should never do because you could really get injured from that. Now, when I punch a wall, I am applying a force to the wall. Remember, a force is any push or pull. And here's a terrible diagram of me punching the wall. I'm really angry, and I've landed my punch against that wall. And so I will draw in red the effect of my punch. I am putting a pushing force on the wall. And so this red force is a force that we can basically call Mr. Pinola punches the wall. According to Newton's second law of motion, this statement that I just wrote down is my action force. It's the action that I just did. I, Mr. Pinola, punched the wall. And notice I punched the wall to the left. Now, let's think back to Newton's third law of motion. Newton's third law of motion said that for every action, there is an equal and opposite reaction. That's the quick way of thinking about it, but we were more specific. We said that for every action force, which I have an example of here, there is a reaction force that is equal in magnitude and opposite in direction. So I am going to now draw a reaction force. Which is going to go in the opposite direction, but have the same magnitude or strength as my action force. So let's make up a number. Let's say that I punched the wall with 50 newtons of force. Well, the reaction force to this action force is going to be a force that is also 50 newtons in the exact opposite direction. So if I punch the wall with 50 newtons of force, the wall is going to punch my hand back with exactly 50 newtons of force. That's what we mean by equal and opposite. It's the equal amount of force that the wall hit me back with in the exact opposite direction. My hand punched the wall to the left, and so the wall punches my hand to the right. So if the action force is Mr. Pinola punches the wall, then the reaction is, as silly as it sounds, the wall punches Mr. Pinola. So yes, it's true, you can be punched by an inanimate or a not living object, at least according to physics and Newton's third law. Let's now take a look at another real-life example of Newton's third law. It's a swimmer, and here we see our swimmer in a pool of water. The swimmer is moving to the right. So the swimmer is moving in the direction that he or she is facing. Now, if you think about how you swim in the water, we swim by pushing the water backwards and moving our hands like this through the water while we kick with our feet. So our hands are not pushing forward. Instead, our hands are pushing the water behind us. And so in this case, there is an action force. And I will show you with one of the swimmer's hands. The action force is that the swimmer pushes the water backwards. Swimmer pushes the water backwards. And let's say that the swimmer used a force of 100 newtons to push the water backwards. Well, let's now think about what Newton's third law says about that. For every action force, this is an action force, there is going to be an equal in magnitude, so 100 newtons, and opposite in direction, so to the right, reaction force. And what is the reaction force in this case? Well, if you think about the last example, the action force was wall punches Mr. Pinola. The action force was Mr. Pinola punches the wall. The reaction force was wall punches Mr. Pinola. In this case, we're going to do the same thing and just flip the words around. So the action force was the swimmer pushes the water. The reaction is that the water is going to push the swimmer. And which direction does the water push the swimmer in? You guessed it, in the opposite direction that the swimmer pushed the water. So the water is going to push the swimmer forward because the swimmer pushed the water backwards. For every action force, there is an equal in magnitude and opposite in direction reaction force. Let's consider now one last example of Newton's third law of motion. Here we have a girl. She's playing soccer. And so a lot of times if a soccer ball goes up into the air, you have to do what's called a header. You have to hit the ball with your head. And for some soccer players, this can be a dangerous thing. If they don't know how to do the technique properly, they can get concussions or they can get seriously injured by heading the ball improperly. So let's now draw a soccer ball. That our girl is hitting with her head. So, can we think about the action and the reaction forces that are happening here? Well, let's start with the action force. The action force is going to be in this direction. And the action force is that the head hits the ball. And notice the head is hitting the ball in this upward direction to the right. Let's say the girl heads the ball with a force of 30 newtons. What's the reaction force to that? Well, let's flip the words around. Remember, for every action force, there is an equal in magnitude and opposite in direction reaction force. So the reaction force to the head hitting the ball is the ball hitting the head with the exact same amount of force in the opposite direction. So there is a 30 Newton reaction force of the ball hitting the girl's head. And so this is why you can get hurt if you hit the soccer ball with your head in the wrong way. That's because even though you are applying a force to the ball is applying an equal amount of force back on your head. So next time you get angry, don't go and punch a wall. And that's because the wall can punch you back, according to Newton's third law of motion. If you apply an action force of 200 newtons to a wall, then the wall is going to apply a reaction force of exactly 200 newtons back on your hand. That's how Newton's third law of motion works. Thanks for watching.